Welcome back. In this clip we'll be covering some advanced terminologies that are common in the lighting industry. Let's first start with what type of voltage from the drivers, and the two types that we see that are used in the LED fittings today: CC, which is constant current, and CV, which is constant voltage. Now, constant current drivers function as a regulated current source. So this puts out a constant current flow regardless of the voltage across the entire electronic circuit. This allows the device to maintain a constant electric current, and those you will find predominantly in things like your downlights, as they have almost no variation across the brightness of the display. Constant voltage, however, they mostly use LEDs constructed in connecting a number in either a series or a parallel form, either a cluster or in a string configuration. Now in this case, if a string of LEDs are connected in a parallel circumstance, there may be an issue in terms of trying to match the current in all of the entire string. Therefore, the use of an external constant voltage driver is preferred. Constant voltage drivers used in applications where multiple LED modules are connected together. They have a fixed voltage, usually 12 volts or 24 volts. A perfect example of this is LED strip. Now, whereas the voltage remains constant, it's the wattage or the drain which can differ based on the length or the output of the strip that's connected at the time. But the voltage remains the same across the entire circuit. Now let's touch upon some critical LED standards. Now, starting with LM79. Now, this code with the lighting industry refers to measuring of attributes over the entire fitting itself. And these tests are often put into what we know or that we've heard of being a photometric data sheet. This information covers a variety of attributes, including total luminous flux, the intensity, power characteristics, efficacy, CRI, and correlated colour temperature. The next code that you may have heard of is LM80. Now, this testing refers to the maintenance of the LED light source, which is the chip. This testing is done under 3 temperature case scenarios. First is 55 degrees, second 85 degrees, and the third being whatever the manufacturer chooses to do it under. Both of these test reports should only be performed from recognised laboratories for them to be relevant. A third one, TM21. It's newly introduced and it projects a lumen maintenance of an LED fitting. That's the entire fitting. The data derived from the LM80 testing is used here, but it doesn't determine the entire life or the time of the failure of the fitting, but it gives you a projected level of maintenance. Since LEDs are in fact semiconductors, typically they will not burn out like halogen or a CFL. Instead, the lighting output reduces over a period of time. This time we refer to as a code called L70. An example of this is if a fitting stated that its life cycle is 50,000 hours at L70, this means that the output of the fitting will have a reduced by 30% of its original output after 50,000 hours. So the maintenance percentage basically refers that the 30% lumen depreciation, we would consider that fitting not to be performing in its duty anymore, and then we would suggest a replacement. Thank you for joining us, and for any more information please visit our website and check out products available online. Thank you.